Good morning, students. We shall study today different types of compounds and we shall find out the oxidation number of elements in those compounds. For example, consider H2SO5. If we have the conventional method, then H2SO5, if we write X for the unknown oxidation number of sulfur, then writing oxidation number of other elements at their tops, we have 1 into 2 is equal to 2, X into 1, that is number of atoms of sulfur in this case is 1, which we usually do not write. Then 5 into minus 2 minus 10. Add them. 2 plus X minus 10 is equal to 0 because the compound is neutral. X is equal to plus 8. By conventional method, the oxidation number of sulfur comes out to be 8. But if we write the electronic configuration of the sulfur, it is neon 10, 3s2, 3p4. In the valence shell, we have 2 plus 4, 6 electrons. Hence, the oxidation state of sulfur can not be more than 6. Therefore, the conventional method is incorrect in this case. Come towards the oxidation state by the structure. HO, you just write that this is the peroxide linkage in the H2S5. Let us calculate the oxidation number of this by plus 1 minus 2 plus X minus 2 minus 2 minus 1 minus 1 plus 1 is equal to 0. X will be equal to plus 1 minus 2 minus 2 minus 2. This plus 1 and plus 2, plus 1 plus 2 cancel with this. We have 2, 2, 4, 5 and 6. That is X minus 6 is equal to 0. Therefore, X is equal to 6. It is correct answer. It is not 8. Take the second. I have taken this neutral molecule. Now I take some ion, S2O8, 2 minus. Again, we have to find the oxidation number of sulfur in this compound. The structure of S2O8 is this. O, double bond O, each have minus 2. This is peroxide linkage, minus 1, and then X and O minus 2, minus 2. This is to be found out. Add all the oxidation numbers of this compound and make it equal to minus 2, that is the charge on the ion. This is minus 2 charge on the ion. This is minus 2 plus X minus 2 minus 1 plus X minus 2 and minus 2 is common. If you just solve this, we get X is equal to 6, which is correct. Come towards the conventional method. S2O8 minus 2, 2 into X plus 8 into minus 2 is equal to minus 2. 2X minus 16 is equal to minus 2. Therefore, X is equal to plus 7. This plus 7 is more than 6, the number of valence electrons. Hence, this conventional method cannot find out the oxidation state of sulfur in S2O8 minus 2. Thanks for watching.